Wednesday, and then you take the test on Thursday. So this is just the same thing we've been working on, but just presented to you in a different form. These what we're working on today, which is geometric sequences. It's just a different type of exponential function. Like, it's to give you something to compare it with. If you were with me first semester, we definitely went over this, and if you were with another teacher, they should have gone over it as well. But it was one of those lessons that got kind of like, I don't want to say lost in the shuffle, but depending on if a teacher was on pace or not, they might have moved it around. So maybe we didn't all teach it at the same time. But you learned about arithmetic sequences. Did anybody not remember going over arithmetic sequences in the first semester? And if you really want to impress me, you could tell me there was a word that could be used to describe arithmetic sequences. Like a sequence is just a group of numbers, a set of numbers. But when that set of numbers is said to be arithmetic, there's a word that can be used to describe the relationship. Yeah, you either add or subtract. Yep, then that's called a common difference. But in addition to that, there was a word that you could use to describe that the fact that the numbers had a common difference between them. One word. Have some Valentine's Day candy that my math book gave me. And I'd be willing to pass. Oh no! Oh man. Still good. Let me get some. What was the color of George Washington's white horse? White. Good. But you're too late with it, so you have enough candy. Nobody knows one word? Nah, that is a word, but no. Linear. The word is linear. Oh, well, you should have said it then. You would have gotten. I have other candy that didn't fall in the trash can. Yeah, linear. Well, for geometric sequences, well, you know how you said common difference? Well, geometric sequences have a common ratio, but the word that can be used to describe them is actually exponential. And that's what we've been working on for this unit, is exponential. There's two different types of sequences. If you were with me, we learned about this with arithmetic. This is actually the same exact slide from arithmetic. I don't know. This is the one here. I don't know how much the other people went. Another word for a definition is a rule. Sometimes they call this an explicit rule or a recursive rule. The difference between the two is if you want to find a missing term that's off in the distance, if I tell you, oh, here's a group of numbers. If this were to continue, tell me what the 57th number would be. Then you're going to want to use the explicit. This is the one that you can substitute into. So that sound I hear right now is you writing that down so you remember that the explicit definitions are the ones that you can plug into, because every once in a while somebody tries to plug into a recursive definition and bad things happen. So explicit definitions can be substituted into. What a recursive definition does is it defines the pattern based on the one before. All it is saying is, hey, every new number is going to be a result of the number before, and then this, like, plus 5 or times 2. Explicits are more common. They can be substituted into. Recursives cannot. Recursives are really only useful if you're going to, maybe find like the 5th number or the 6th number, and then you can kind of do it by hand. Now, there's a couple of different formulas that you could use for either an explicit definition or a recursive definition, but my advice to you is let's just focus on the ones on the right. Because I don't control what's written on the tests and quizzes, my guess is that's the one that's going to be used. The only difference between the two formulas that I have written here is what you consider to be the first in the sequence. Do you consider the first number to be the first number or number 0? Like if I were to count how many people are in this row right here, and I say, okay, Nakai is 1, N is 2, and Marquise is 3, that will be one way of saying it. But then if I say, well, look, Nakai is not going to be the first person, he's going to be the 0 person in this, and then N is the first person. That would be, it's just a matter of what you call the first number. Is the first number really the first number, or is it the 0 number? If you consider it to be the 0 number, then you would use a formula on the left. That kind of has its use more in word problems. If you're saying, hey, Caleb is going to start a new business selling Skittles, and he has 37 bags of Skittles left over from last year when he tried doing the same thing, and now he wishes to sell an extra 50 bags of Skittles every week. Well, if they didn't want to know, okay, how many bags of Skittles will he have sold in 10 weeks? It depends on whether you count the initial amount of Skittles that he had as having been after the first week or before the first week. That would determine which one you use. But again, let's just focus on the one on the right. So let's call the initial amount f of 1. That's the initial amount. Geez, on every single exponential function that we've dealt with before, what came right after the equal sign? The initial amount. What do you think this f at n stands for? Yeah, the final amount, like which is the amount we're looking for. And in these type of sequences, typically that's like, hey, are you looking for the 10th number, the 15th number, the 20th number? What number are we searching for? That R means today common ratio, but what is that taking the place of based on the terminology that we've used in the last couple of weeks? Being that it's the base, it's underneath the exponent. What have we called that in the last few lessons? The growth factor, yeah. Okay. Well, now it's called the common ratio, but it's the same structure. And then finally we have the exponent, and in the exponent it's n minus 1, where the n is the number of the term in the sequence you're looking for. I know this might seem like a foreign language right now, but as long as you're like paying attention and you don't have your head directly on top of your arm, which is directly on top of the folder, which is directly on top of the desk, you should be fine. Was there a flower originally inside that Skittles? Because that would have been nice. No? You put like a flower and then you fill the vase with Skittles and stuff so that the flower can eat Skittles instead of water. Probably would have died, but still, it would have lived a good life. A recursive definition, okay, again, we're going to focus more on this one here, where we're going to call f of 1 is the initial amount, but a recursive definition is just broken into two pieces. And think of it more as a language as opposed to a formula. It's just a way of reading it, where they're going to tell you, hey, this is the first amount, and every amount that comes after is the amount that came before it times some common ratio. Here I have explaining what this means, common ratio. Here, let's just get the party started. Let's start doing some examples so this can make sense. This is a kind of a fill-in-the-blank page here. A geometric sequence is a sequence of terms that have a blank between them. Fill in the blank. Common ratio. Let's build on that a little bit more, because hey, Mr. Romero, I heard you say that before, but what the heck are you talking about? What do you mean common ratio? Well, what does the word ratio mean in math? What does the word ratio mean in math? It does mean fraction, very good. And what operation are you doing in a fraction? Dividing, very good. And because division can always be expressed as multiplying by a reciprocal, you can use the word common ratio to describe going from term to term by either multiplication or division. And just finished saying that back in the first semester when she learned about arithmetic sequences, to get from one term to the next, what operations were you doing? adding or subtracting. Well, today we're going to be multiplying or dividing. The explicit formula is the formula that's used to find the blank of the sequence. You know what? I'm not even sure what they're talking about there. I don't know. I don't have a key for this. The explicit formula could be used to find a lot of things, so I'm not sure what they meant by that. Let's just skip that here. But what we can do is let's focus on this one. What is the explicit formula for any geometric sequence? Assuming that we're using the one I told you we're going to use most often. It's literally just copy and paste from the first page. It'd be great if you memorized it and you didn't have to look at it, especially considering that we've been working with exponential functions for. No. F of n, which means that some final amount, is equal to f of 1, which is the first amount, times a common ratio to the power of, okay, this is the new part, n minus 1, yeah. And on that first page, I explained to you what the n stood for. Where a, well, here they use a something. They use a different notation. Here, I used an f of 1. Here, they use an a of 1. It's the same thing. Where a1 is the first term of the sequence, and they use an r here also. I just called it something different, but it's the same thing. I'm using function notation. They're using what's called the subscript. A sub 1. Okay, how about the recursive formula for a geometric sequence? Yeah, they're going to put like f1, or they might put a1 is equal to, and then they're going to give you the number. I just wrote it as, whatever that they're going to do is give you a number. And then they'll write and every number thereafter is equal to the common ratio times whatever the first number is. Remember, instead of f1, you could see this. It's the same thing. You can see that. It's another way of writing first amount. What's your favorite Skittle? You don't have a favorite? Ask my mom? What is it? Oh, you eat them all. I don't think my mom eats Skittles. I think the greatest thing in Skittle history is when they changed the green to sour apple, as opposed to they used to be lime. Maybe you were too young for that. Did you ever eat Skittles when they used to be lime? Tasted terrible. Most people would say red. I think I like orange better. Martha, you like orange too? I think that's the best Skittle. You know what's not the best Skittles? Those tropical flavors. Those are not good at all. I don't like those at all. You like the tropical flavors?
Yeah, the spicy ones.
Spicy ones?
Yeah, the spicy ones.
No, the sour ones are pretty good, but then they your whole mouth starts to feel. Okay, so for these first two examples, real quick, the key here is that you're already being told that we have a common ratio. They're not asking you if this is geometric, they're telling you it's geometric, and this finding a common ratio. So if we already know it's common, we don't have to test every consecutive set of numbers. There's going to be some in the future now where they're going to ask us, and we're going to have to test. Here we don't have to test. We can get any two numbers, and remember ratio means, and fraction means divide. So the key is still you have to jump in front and divide the number behind it. So what is 8 over 4? 2. And if you wanted to test it, you could go to each consecutive one. What's 16 divided by 8? Also 2. What's 32 divided by 16? Also 2. Question or are you going to answer? Oh, I'm sorry, right. Thank you. Yeah, because the n minus 1 stands for the number that came before it. Sorry about that. All right, so for the next one, again, you can get any two numbers you want in a row. Here, you might like the smaller numbers, especially if we're calculator challenge, like some of us are in here. What's 4 over 16? Yeah, don't put 16 over 4. Your common ratio there is not 4. The numbers are getting smaller. When the numbers are getting smaller, actually, you know what? Maybe we should write this down here. I don't even know how to write it. You can write it however you want. Let's do that. I'm going to dictate it to you, and you can write it however you want. Okay? When the numbers are getting smaller, your common ratio has to be between 0 and 1. So, numbers, I'll write it for you. And the numbers are getting smaller, that means your common ratio has to be between 0 and 1. And it's actually the absolute value of the common ratio. It doesn't matter if it's negative or not. I'll let you know what happens when it's negative. If the numbers are getting bigger, and you saw this before, you know, what did we call it before when the common ratio was between 0 and 1? Well, we didn't call it a common ratio, we called it a base. Not a compression. What did we call it when the base was between? Decay, good. When the numbers were getting bigger, what did we call it before? Growth, yeah, well that's here, a common ratio is greater than 1. Okay, but now there's one new concept to look for, and that's when the signs change. We didn't have this before. When the signs like let me do a better word. How about alternate? Let's do that. When the signs alternate, when you go from positive to negative, the common ratio has to be less than 0. What type of numbers are less than 0? When do you have lunch? What I'm saying, the bell hasn't rung for lunch yet. Let me just go back to class then until then. And, so yeah, this is simulating kind of like a decay. What I didn't include it on my notes. Should have. Well, you know what? I know why, because it'll come to me. They have another word other than growth and decay, but it's not really used for sequences. It's used for something else called series. It's like when you have to add the numbers. It's slightly different, but I was gonna put the words in also. I just forgot to write it down. You don't need to know it, but if I think of it, I'll write it down. What is 4 over 16? Yeah, 1/4. The reason why I bring all this stuff up is because, again, notice how from left to right, the numbers are getting smaller. So if you put that the common ratio is 4, that would be wrong. It has to be 1 over 4. Find the common ratio, the explicit formula, and the seventh term. Ooh, fun. Okay, so they are telling us that this is common, so we don't necessarily have to test each combo. Let's find the common ratio, which is then going to be needed to find the explicit formula, which in turn we will use that to find the seventh term. Okay, the common ratio would be here. Get any consecutive set of numbers, jump in front and divide the one before. I'll just do 3 over 6. So what's my common ratio? 1/2. Very good. What else do I need in order to be able to write an explicit formula? I need the common ratio, but I need one more number. The first number, and that we know by looking at it. What I called f at 1. Here, let's just call it this so it's not. I don't know. Do you think is it going to confuse you more if I use a sub 1 for the first? Should I use f at 1 or should I use a sub 1? That's fine if I use that. Okay, so a sub 1. You're probably more likely to see that on the test. So a sub 1 here is going to be 6. So now let's write the explicit formula, which is going to be f of n. F of n is equal to, first it's the initial amount, which is 6 times. For ratios, they use and we've been using parentheses, but they use the dot a lot. for sequences. So I'm just going to use a dot. Times 1/2 to the power of n minus 1. So then for the last part, what's the only thing we got to do to find the seventh number? Because explicit formulas are the ones that can be substituted into. I'm going to plug in a 7, 4, n. So this is just saying if this were to continue, what would be the seventh number? If you wanted to find this recursively instead of explicitly, I would just go from, I would use that common ratio of 1/2 and just keep on multiplying each number times 1/2, which is the same as dividing by 2. So far, how many numbers do I have here? 4. So the next number I find would be the fifth number. The next number I would find would be the 6th, and the next number I find would be the 7th. Then how do I find every new number? Just divide by 2. That would be another way of doing it, but I'm going to find it explicitly. So the seventh number is equal to 6 times 1/2 the power of 7 minus 1, which is the same thing as saying 6 times 1/2 to the power of 6. We all know how to use our calculator. Guy's going to use his calculator. Caleb is going to use his Skittles as an abacus. You've seen an abacus before, Martha? The seventh number is, and just so you know, like another way of writing this, because I don't write the test, but you might also, if they don't use function notation, you might see this. They might write it like this: a sub 7, a sub 7, a sub 7. That just means the seventh number. Just means the same thing. The seventh amount. I'm gonna leave it as. I guess we could write it as a fraction, but I think it's easier for you to just write it as a decimal. 0.09375. Anybody get anything different? If you don't know how I got that, let me know now. Read. 1 thumb up, 2 thumbs up, 1 up, 1 down. Are you understanding it? Yes, no, 2 thumbs up? No? Thumb sideways? So. Okay, what looks a little bit different here for example number 4? What looks a little bit different with example number 4? Yeah, we have negatives. But are the signs alternating? Are we going positive, negative, positive, negative, positive, negative? No, we're not. They're all negative. So the only time your common ratio is negative is if the signs alternate. Since the signs don't alternate, my common ratio is going to be positive. The way you can find it is just divide any two numbers that are consecutive. My common ratio here is 3. So now the explicit formula here. Let's write it their way. This is another way of writing it. A sub n is equal to, what's the first number? -4 times common ratio, which is 3, the power of n minus 1. So now they want the 10th term. So a sub 10 would be another way of writing it. If you wrote it my way in function notation, it would be f of 10. It just depends what book you get it from. It would be -4 times 3 to the 10 minus 1. And that's going to be a big number. It's going to be negative, but it's going to be very, very negative. A sub 10 is equal to -4 times 3 to the 9th. -4 times 3 power 9. It's not that big. I thought it was bigger than that. Did I type that in there? I thought it should have been bigger. 3 power. Again, I'm getting -78,732. And doesn't agree? Okay. I get worried when n doesn't agree. right, the fifth term is 1792. The common ratio is 4. Write the explicit formula. In order to write the explicit formula, what did I tell you that we need? Yeah, we need the first number. We don't have. That's the problem. We also need the common ratio that we have, but we don't have the first number, so we're gonna have to use this to find it. Instead of putting the final number, I'm actually gonna write the final number, which is 1792 equals this a sub 1 that I'm looking for, times the common ratio, which is 4. And it knows that it's a fifth term to the power of 5 minus 1. The important thing is here, how many unknowns are there? There's only one unknown, so I can solve for it. So I will put 1792 is equal to a sub 1 times 4 to the 4th. I would use my trusty calculator not to find 4 to the 4th, 256. So 1792 is equal to 256 times a sub 1 divided by 256. 1792 divided by 256 is 7. If you're not a big fan of algebra and you're kind of used to thinking more recursively as opposed to explicitly, could I have found this another way? You could have just divided by 4. Yes, if the common ratio is 4, that means that from left to right, you're multiplying by 4. But in this case, I want to go backwards. I want to go from the fifth number to the first number. So instead, I would divide by 4. And then you would just do so one by one until if you're at the fifth number, then you would go to the fourth number, and then the third number, and then the second number, and then the first number. Eventually, you would get to 7. Am I done? No, because they asked for the explicit formula. So the explicit formula is a sub n. Here, I'll write it both ways to hopefully avoid confusion. I'll write it 2 different ways. On the original notes, I had it in function notation. Here they have it in sub notation. In both instances, I would write a 7 first because that's the first one. In both instances, I would write a 4 next because that's the common ratio, and in both instances, I would write to the power of n minus 1. So the only difference is what? If I then ask you to find, hey, what is the 54th term, what would you have to do? Put a 54 in front. That number's going to be too big. Your calculator might explode. Don't want that. Any questions there? The next one got cut off. There's no question there. It says to find the following, but then there's nothing to find. I don't know why that got cut off, but let's just get to the next page. There's plenty of questions there. Notice how here they are not telling us that the sequence is geometric. They're asking us to decide. And then also to explain. So number 1, how would we decide if a sequence is geometric? Say it better. Oh, no, say it better. Does it have a common ratio? So that's going to be a yes or no. But then when you explain, if it's yes, what do you think would be a good explanation as to why it's yes? What do you think you'd have to give to support it? Just give the common ratio, sure. If it's not, then you would say there is no common ratio. So let's do the first one, right? The difference here is we have to test each one. You got to see if it's common. So negative 4 divided by 1 would have to be equal to 16 divided by negative 4 would have to be equal to negative 64 divided by 16. Do you see something happening here for the first time? The signs are changing. So if we are going to have a common ratio, it better be negative. Now, another way of writing this is I've done it before like this, where you do like these little loops. So like, what's negative 4 divided by 1? It's negative 4. What's 16 divided by negative 4? Negative 4. Do we have a common ratio? So I would write yes, and my explanation would be that r equals negative 4. Divide, division. How do you say division in Vietnamese? How about the next one? Yeah, I know, because look here, this is 5 over 2. This is 10 over 5. This is 13 over 10. When you divide those, you're going to get different numbers each time. So this would be no, and the reason would be that there is no common ratio. How about the next one? Yeah, no, you can tell there's no way. Because from here to here is this is times -1, and then from here to here is 7 over 5, and this is -7 over. This is also -1. That's not going to be. I mean, there might be some pattern there, but it isn't geometric. How about the next one? Can you give me another reason other than that there isn't a common ratio as to why number 4? It's arithmetic. Very good. Number 4 does not have a common ratio. What does it have? Common difference. Hey, Kayla. Just sit here. Oh, somebody likes you. Caleb got Skittles. So just want to make sure everybody knows that. Did you get Skittles? No, you did not. Caleb did. Did you not get any? Oh, this is impossible. It's not your regular period 11. Don't expect it again. I have red out pencils. And then you're here next period anyways, right? So we're gonna finish this quickly as we can. I'm not gonna write the rest of these. I'll just do these verbally. The next one is it geometric? Yeah, I can tell like by looking at it, because from 3 to 12, I know it's times 4 if it were to be geometric, but 4 times 12 is not 21. Okay, how about number 6? Huh? It actually it looks like it to me. Let's see. Let's write this one out. This one's gonna be a yes. It looks like. How can we tell? Well, let's see. 5 over 2. Remember that dividing is same as multiplying by a reciprocal. So it's times 1 over 5. The 5's cancel. That gives them 1/2. 5 over 4 divided by 5 over 2, which is times the reciprocal, is 2 over 4. 2 over 4 is 1 over 2. 5 over 8 divided by 5 over 4 is the same thing as saying times 4 over 5. The 5's cancel out. 4 over 8. So, yes, this is geometric. What's the common ratio here? 1/2. Every new term is half the term before it. What did I tell you another word for rule was? Okay, definition. And what's another word for definition that we saw already today? Principle. No. That we saw today. So like earlier on, the word definition was attached to explicit and recursive. On the previous page, what word do you see attached to? Yeah, formula. So they're just asking you to write, when they ask for rule, write the explicit formula. I don't know if I'm going to do all of these, but we'll do them until it stops being interesting. Now, this is already implying that we have a geometric sequence, so we don't have to test it out like we did the first 6. Let's just write it. Do you want me to use function notation or that sub notation? Let's use the sub notation because I think that'll show up on the test because I'm not the one writing it. So what do we need in order to write an explicit formula? The first amount and common ratio. Here we have the first amount. We don't have the common ratio. Can we tell by looking at this what the common ratio is? negative 2. To get from one term to the next, it's times negative 2. So r is negative 2. What is my first amount? Negative 5. So a sub n is equal to, so a sub n is equal to negative 5 times negative 2 to the power of n minus 1. That's the first part. As you saw on the quiz before, you would assume that it's likely that you're going to end up with some type of questions that have multiple parts, like a part A, part B, part C, and then assume that maybe they might ask you for the geometric sequence on one of the parts, but then they're going to ask you to find the missing term. Here they want a sub 6. So where am I going to put the 6? Negative 5 times negative 2 to the power of 6 minus 1. Use your fingers. What is 6 minus 1? It is 5. So a sub 6 to the negative 5 times negative 2. At this point, I mean, you can actually do this in several steps if you want. You can just do it in the calculator in one step if you'd like. So negative 5 times negative power 5. I'm getting 160. I'm getting that a sub 6. Did anybody get anything different? I want to do one that has okay, let's do number 9. Since we already know this is geometric, we don't have to test each one. Can you tell me what the common ratio is here? Well, wait, what do you mean 3 over 2? I don't get it. I don't see a 3 anywhere here. How'd you get that, Mr. Brown? I don't see a 3 or a 2. Well, so what's 6 over 4? Yeah, 3 over 2. What's the first amount? It is 12. So let's write it first. A sub n is equal to 4 times 3 over 2 to the power of n minus 1. We're not scared of fractions. So a sub 6 is this can't be simplified. So a sub 6 is equal to 4 times 3 over 2 to the power of 6 minus 1. 6 minus 1 still gives you the exact same thing, which is 5. If you put that in the calculator, that's fine. I can live with it. But since we learned properties of exponents earlier this year, what happens when you take a fraction to a power? What are you allowed to do when you take a fraction to a power? Distribute 3 to the 5th. 3 to the 5th. So a to the 6 is equal to 4 times 243. I know that 2 to the 5th is 32. And I know that 4, again, if you just put a decimal, that's fine. I can live with it. I'm just trying to change things up a bit. I know that the 4 and the 32 reduce. 243 and 8 can't be reduced. So you can either write that a sub 6 is 243 over 8, or you can just put the decimal equivalent. I'm getting 30.375. What I typically would be more inclined to do, like if as part of my sequence they gave me numbers that had decimals, I'd be more inclined to write my answer as a decimal. Do you see any decimals here on number 9? If anything, I see a fraction, so I like to stay in fraction town. But I would accept either one as long as you don't round. Here, let's skip to number 14. If we have more time, we'll come back to this page, but I want to get to every page. Actually, we'll do 14 and 16. Both of those. Okay. What's different about 14 and 16? Huh? What do you need? We want to write the explicit definition, right? What do we need in order to write the explicit definition? We need the first number and common ratio. Are they giving us both of those?
No.
No, they're not. Because they're giving us, what number are they giving us? The third number. I guess I don't want to give you back. I'm trying to think of a way to water this down the easiest. I think you can do this. I'm going to try something that I think you can do. But I want to test it because I'm not sure you can do it. So I'm going to test it out afterwards to make sure it works. What I am proposing to you is I believe that you can use this number as the first number, but then you got to make an adjustment. I'll show you the adjustment. Now, you know what though? You're not going to be able to use it for the forget it. All right, so let's just do this. Let's find a sub 1 recursively then. Meaning, if the common ratio, meaning if we're going this way, is times 1/2, what do you think going backwards would be? Huh? Okay, dividing, but what is dividing by 1/2 the same as? Times 2. We'd be multiplying times 2. What is 1/4 times 2? It's 1/2. What's 1/2 times 2? Yeah. So my a sub 1 here, my first number, if I went backwards, is 2. My common ratio is 1/2. So my eddy amount is equal to the first one, which is wait there. I said 1, but I wrote 2. A sub 1 is 1. Ratio is 1. It's gonna be 1 times, when that initial amount is 1, you don't even need to write it. So 1 times the common ratio, which is just 1/2, the power of n minus 1. What number did they want us to find? 6 number, so a sub 6 is equal to 1/2 to the 6 minus 1, which is 1/2 to the 5th, which is 1/30. All I did was I went backwards. Instead of counting in this direction, I went backwards 2 so I could find what the first number was. I used the common ratio to go backwards. Look, maybe number 16 will be easier because now they're using decimals, so you can use a calculator, right? If my common ratio here is negative 0.5, that means to go to the right, I'm multiplying by negative 0.5, which means to go backwards, I would do. What's the opposite of multiplying by negative 0.5? Well, it's actually times negative 2, but let's say that you didn't even know that. The fact is that because it's a decimal, you can just use the calculator. You don't have to worry about reciprocals. So I would just do, okay, right now we're at negative point. Follow along with me if you have a calculator. Right now I put in negative 0.25 in my calculator. I divide by negative 0.5. My calculator, negative 0.25 divided by negative 0.5. My calculator tells me positive 0.5. What number in the sequence is that positive 0.5? The fourth. Now let's go back one more, right? Because they started off with the fifth. So now let's go to the fourth. Sorry, I have the fourth. Let's go to the third. So divide by negative 0.5. I get that the third number is negative 1. Divide by negative 0.5. I get that the second number is 2. And if I divide by negative 0.5 again, I get that my first number was negative 4. Does anybody not know how I got that? No, I didn't write it down, but I explained what I was doing. Yeah, because you don't have a calculator. If you had a calculator, it'd be easier to follow. All I did was I got this fifth number. They're telling me that the fifth number is negative 0.25, and to go backwards until I got to the first number. So this would be the fourth number, third number, second number, first number. What did I do? What does each little hump here represent? What did I do in every little hump? To go backwards, if going forwards means multiplying by negative 0.5, what did I do each time that I went backwards? What is the opposite of multiplying by negative 0.5? Dividing by negative 0.5. That's all I did. But now I have the first number, and they already gave me the common ratio. So I'll just write this out using decimals. A sub n is equal to the first number, which is negative 4 times negative 0.5 to the power of n minus 1. I confused you already? What are you confused about? Don't tell me what you're confused about. I can't help you. Don't tell me what you're confused about. Also, I'd like to point out for the record that you also do not have a calculator. Is anybody that does have a calculator confused? All I do is go backwards. In order to be able to write the explicit definition, I need the initial amount, and I need a common ratio. They gave me the common ratio. I did not get the initial amount, because since I know how to read subnotation, I can tell that they. They give me the fifth amount, so I have to go backwards to find the first amount. Ended up being negative 4. If I started with this number and go back to the fourth, third, second, and first, each time divided by negative 5. Now let's find the sixth number. Negative 4 times negative. And really, here, how about an even easier way? Since we're already at the fifth number, what would be an easier way to find this without even having? Let's do it that way. Instead of using the explicit formula, if we already know what the fifth number is, and I need to know the sixth number, what's a quicker way of doing that? Not add. When you have a common ratio, to go this way, you multiply. If you go this way, you divide. So what can I do to find the next? If I'm at 5, the next number is 6. So like, how would I find the sixth number? Yeah, multiply these two. No, forget it, minus 1. This is the fifth number. Every time I go to a new number, I'm multiplying by the common ratio. So if I left off at negative 0.25 times negative 0.5, that gives me 0.125. The same thing would have happened if I would have gotten this 6 in here. The exact same thing. All right, I didn't get to the word columns, but next week we have 2 days of. Next week we have. You can try some of these if you want, and if you want to come in early, I can help you. If not, I'll try to get to some of these next week as part of the review. Just remind me, because somebody remind me that I have to do the word columns.